Long before steel cranes or diesel engines, ancient Egypt raised monuments that still force the modern world to ask how such building was possible. The pyramids were not accidents of mystery. They were the result of planning, labor, mathematics, and a state powerful enough to organize all of them at once. Egypt's builders worked without modern tools, but they did not work without intelligence, system, or engineering discipline. Their greatest advantage was not a machine. It was an entire civilization organized around the Nile, royal power, and collective labor. Each year, the Nile flooded, shaping agriculture, transport, and the rhythm of life across the kingdom. That flood cycle gave Egypt something crucial: seasons when many farmers could be redirected into state labor projects. This is one reason the old myth of pyramid builders as a vast army of slaves is too simple and often wrong. The evidence points instead to a workforce that included skilled laborers, seasonal workers, quarrymen, haulers, craftsmen, and administrators. At the center of all of it stood the king, because pyramids were not just tombs. They were statements of divine kingship in stone. A pyramid complex linked royal burial, religion, memory, and political authority into one monumental landscape. Building such a monument began long before the first block was moved. Surveyors had to choose the site, mark the axis, level the ground, and connect the building to nearby quarries, work areas, and river transport. The builders of the Great Pyramids selected locations near the Nile, but also on stable desert edges where huge monuments could stand securely. Limestone for the core could be quarried locally, reducing the distance for much of the heavy material. Finer casing limestone came from places like Tura, which meant transport by river had to be integrated into the plan. Granite, used in some internal spaces, and structural elements came from much farther south at Aswan. Moving stone from multiple sources required a supply network, not just brute force. Egyptian quarry workers cut blocks with simple but effective tools, including copper chisels, stone pounders, wooden mallets, and leverage. Copper was softer than iron, but the builders compensated with repeated sharpening, specialized use, and smart division of labor. Harder stones could be attacked with dolorate pounders that battered the surface again and again until it yielded. Once cut, the stone had to be moved, and this is where organization mattered as much as muscle. Blocks were loaded onto sledges and dragged by teams that could coordinate their effort over prepared ground. Ancient art and experiments suggest that wetting the sand in front of sledges reduced friction and made hauling more efficient. That does not make the task easy. It makes it understandable. Water transport was another secret of Egyptian building power. The Nile served as a natural highway that connected quarries, workshops, and construction zones across long distances. Boats could carry stone, wood, food, tools, and people in volumes that overland transport alone could never match. Administrative precision was essential because thousands of workers needed rations, housing, schedules, and supervision. Scribes tracked materials and labor, turning bureaucracy into a construction technology of its own. Granaries and storage facilities mattered because monumental building depended on feeding the workforce consistently. Bakeries and breweries were not side details. bread and beer were basic fuel for mass labor in ancient Egypt. Workshops produced tools, fittings, ropes, wooden elements, and all the practical equipment needed to keep a building campaign alive. At large sites, the pyramid rose not from one miracle, but from an entire ecosystem of support. The layout of the pyramid itself also required geometric confidence and careful alignment. The builders achieved remarkable orientation, bringing the sides of major pyramids close to the cardinal directions. How they did this is still debated, but solar and stellar observations likely played a role in aligning the monument. The foundation also had to be made level, because even a small error could spread across the whole monument. Then came the most debated question of all: how were the blocks raised? No single answer has solved every stage of pyramid construction, but ramps remain the leading family of explanations. Straight ramps, zigzag ramps, encircling ramps, and internal ramp theories all attempt to explain how height was gained as the pyramid grew. It is possible that different methods were used at different stages rather than one perfect system from start to finish. Levers may also have helped position blocks more precisely near the upper courses. As the structure rose, the work became not only harder but more exact. Internal chambers, passageways, and relieving spaces demanded planning that reached far beyond stacking stone. The outer casing stones, once polished and fitted, gave the pyramid a bright, clean geometric form, unlike the rough-stepped appearance we often imagine today. Causeways and valley temples connected the pyramid complex to the river and to ritual movement through the landscape. The project therefore united architecture, transport, religion, and political symbolism in a single controlled design. Recent discoveries, including administrative texts, such as the Diary of Merer, make the process less mythical and more human. They show organized transport of limestone and reveal that logistics were central to the achievement. What still amazes us is not that Egyptians had magic, but that they could coordinate so much labor so effectively with simple tools. The pyramids were built without modern technology, yet not without engineering. They were built by a civilization that turned order, manpower, and river logistics into power. That is why ancient Egypt still stands as one of history's greatest examples of how disciplined human organization can create the seemingly impossible.